We're going to start um, by solving natural log equations. This is our fourth example. In the previous example, we had an exponential to start with, and then we had to rewrite it as a log to end up solving it. In this one, we're going to start with the log and then have to rewrite it as an exponential. And you should recognize that, or you will start to recognize that if you notice where the variable is. The variable is in the argument. Well, the only way to get that out is to end up rewriting it as an exponential. That's how we're going to get it out. So think about your properties. Think about, we know how to rewrite. We know to use the power rule, the product rule, the quotient rule. And on this one, we only have one log expression. So we would not use the power rule or the product rule. I'm sorry, we would not use the product rule or the quotient rule. I don't know what the ln of x is. And I have this 5 out here, and some of you may want to say, hey, we could use the power rule and put the 5 right there over, like the ln of 6x to the 5th power. Well, we could, but then we would have x to the 5th, and we're trying to solve for x, so taking x to a higher exponent at this point is not going to help us solve. It's going to get us deeper into the hole of not knowing. So that's really not the strategy we want to use. Instead of using the power rule here, what I want you to see is that this 5 out front is being multiplied. So besides the power rule, which again, x to the 5th, that's not going to help us, or 6x to the 5th, besides the power rule, what else could we do to get rid of this 5 if it's being multiplied? Right, we could divide both sides by 5, and that's what we're going to do. And we'll divide both sides by 5, and then we'll have the natural log of 6x equals 8/5, which is the same as 1 3/5 or 1 6/10. All right, so now we have isolated the log, and we have the variable is in the argument. We can't go any further, so we're kind of at the wall. And when you're at the wall and you can't go any further, you can always rewrite it. And that's what we're going to do. We're going to rewrite it in exponential form, or exponentiate, as my students used to say in years past. So that's what we'll do, remembering this is base e. So we'll say e to the 1.6 equals 6x. Oh, yeah, that was very helpful, wasn't it? Because now the x is over here. I can use my calculator to determine what e to the 1.6 is. That's good. I can isolate this variable x by dividing both sides by 6. And so let's do that. Let's get our calculators, and I will find the e. Remember, it's on the ln button as the toggle, so second ln, and I get that e to the x. So I'll just type in a 1.6. You could put in 8/5. 1.6 is just as good. Go ahead and hit enter, and I get 4.95 and change. And now I'm going to divide that by 6, and this is what we get. So I want to round that to the nearest 100,000th, or 5 places past the decimal. And so I'm going to use my wavy equal signs for approximately. And we will say that it is 8255, and then it's 054. Well, that's going to round to 1. All right. And if I took this value, substituted in right there, and said 5 times the natural log of 6 times 0.82551, close parentheses, and hit enter, guess what I would get? 8. Okay. So you can check your work, and I would encourage you to. Let's try another one. Very similar, but just slightly different, because I wanted to give you one like that you'll see in your assignment. So let's say we have the natural log of 2x minus 3 cubed equals 6. All right, so how is this one any different than the one that we just did? Well, the one we did originally has already had the 5 out front, but think, where was it? It was right here on the 6x. So what do we have? We have 2x minus 3 as our argument in parentheses, and then who out front? Or outside of that, sorry, not out front, the 3. So we can use the because what are we trying to do? We're trying to figure out what x is. It says solve. So I've got to figure out who he is. I can take this 3 and put him out front, and then he'll look just like this. Okay. So let's use the power rule. Take this 3, put him out front, and now I have 3 times the ln of 2x minus 3 equals 6. Yep. So now what? Well, what did we do over here? Well, we were trying to work our way down to isolate the x. And that's what we're going to need to do here. Let's divide both sides by 3. So divide by 3, and I have the natural log of 2x minus 3 equals 2. Now what? Well, I'm done, right? I can't do anything else. I'm kind of at the wall. So remember, when you're at the wall, what do? Rearrange. Rearrange. So I'm going to say, let's put it in exponentiate form. So I'm going to say e raised to the what? Second power equals 2x minus 3. And then it's just working backwards to solve for the variable. So let's add 3 to both sides. So we'll come over here. My pen is not cooperating. So now we'll say what? Solve for x. So we'll add 3 to both sides. E to the second plus 3 equals 2x. And now divide both sides by 2. Now, here's the deal. This is the answer, but we can simplify it. So don't round until the very end, and don't try to put too much of this in your calculator at once. Let's do e squared plus 3, and then hit enter, and then divide it by 2, okay? Because sometimes when you try to put too much in your calculator, you make a mistake with the calculator. So I'm going to say second ln, and then the e pops up. I'll type in the 2, so I now have e squared. And if you'll notice, look where my cursor is. It's still up in the exponent spot. So I need to push the right arrow button once to get the cursor out of the exponent spot. Okay, careful with that, otherwise you'll get strange answers. Now I'm going to say plus 3, and when I do that, and I'll hit enter, and I get 10.389. And then I need to divide all that by 2, and I have 5.194528. So x is approximately 5.194528. So I'll round him to 3. And if you take that value, substitute it back into the original equation for x, you will find that, in fact, it does approximately equal 6. So thanks for hanging with me through this. Remember, base E and Ln aren't to be feared. It's just another base. However, it is an amazing base that shows up as you continue to explore in calculus later on in 2 years from now. You will be very familiar with E and Ln.